Hi, thank you very much. As you're kind enough to say, I'm Andrew Waugh from Waugh Thistleton Architects, and we are an architecture practice based in East London. And for the last 20 years or so, we have been involved in developing timber construction, designing timber buildings, researching into timber, thinking about the implications of architecture, of construction on our environment. And this for us is primarily around housing. So rising populations, especially in the UK, increasing urbanization, does deliver a massive housing need. And these are public problems. And we see our practice, our business, if you like, as a purpose-driven business to solve public problems. Now, in Europe, across the Western world, we measure the carbon implications of our buildings, primarily in terms of the operational carbon. So when we build a building, obviously we haven't used it yet, so 0% of the carbon of that building is the operational. And as we measure it over 60 years, more than half of that carbon of the building is operational carbon. And the materials and the construction process that goes into that, which starts at 100%, after the 60 years that we're measuring the buildings, is less than half. But we don't have 60 years. We barely have 20 years in order to really get our house in order, to start thinking seriously about the implications of carbon in construction. And the operational carbon after 20 years is about less than a third. And that's really not taking into account lots of the massive advances that are happening in terms of reducing the carbon in energy production. But the building materials and the construction processes account for 2/3 of that carbon footprint within the next 20 years. And given the massive housing need that we have, 300,000 new homes a year in the UK alone, this is an incredible carbon burden for our planet to bear. So we have been looking, as I was saying, at building in timber for some years now. In 2008, we built a 9-story, probably the first one, a 9-story timber building, so entirely made from timber from the first floor up, timber lift shafts, timber staircases, external walls, internal walls, floor slabs, everything. And it was a joy. And we were able to build this building purely on the basis that we could demonstrate to our clients that it was faster and more cost efficient to build in timber. This was not a project which was kind of permitted on the basis of carbon savings. And you can see really simple process, the whole building built, excuse me, in 27 days by 4 people. Much less waste because of the prefabrication, very quiet, fewer deliveries, and weighs less than 1/5 of the equivalent concrete building. And we built a lot more since then, about 25 across the UK and France. This is the biggest one we built, 17,000 square meters. Would have weighed 10,000 tons in concrete, weighs less than 2,000 tons in timber, and takes 17,000 square meters of space, about 800 people, which is about 2,500 trees. So just about 3 trees, just over 3 trees per person in the building, and really fast as well. In fact, you can see how fast by the time the train's gone past, the building has finished. Now, one of the things that we've become increasingly obsessed with as a practice is really about the construction process itself and the carbon burden of that construction process. Now, we know that we've been building in the same way for 100 years. And if you look back, since 1966, a very important date, obviously, in England, the productivity in construction has actually gone down by nearly 20%. Whereas in industry, manufacturing as a whole, it's gone up by 230%. We're making buildings in the same way, but just slightly more slowly and slightly more expensively than we were even 50 years ago. And we can see that. Look at the way we made cars over 100 years ago, 150 years ago, and the way that we make them today. Massive advances. And yet, in terms of construction, it hasn't really changed. Now, we've been involved with a number of different cross-laminated timber modular factories over the last 3 or 4 years. And the advances, the opportunities for that are fantastic. So because each one of these big panels of cross-laminated timber is going through a cutting machine, the file that feeds that cutting machine can be completely different every time. And so the timber, which is a factory process going through in the same way, can be cut a completely different way. So opportunities for variation within that kind of modular housing are fantastic. So we're currently on site in East London, building 65 affordable homes for social rent in a low-cost area of East London, and that will be finished this summer. Now, an important part of our practice at the moment is our involvement with the Build in Wood program, which is a European-funded Horizon 2020 research program, working with 21 partners in 12 different countries across Europe. And we are leading the first couple of stages of that. And that really is about understanding the circularity, the opportunity of construction in timber, and really highlighting what I was earlier discussing in terms of that sort of, attempting to meet our Paris targets, and who knows, for Glasgow, attempting to meet those targets, and realizing, understanding, illustrating that we will not make those targets with business as usual, producing buildings from concrete and steel. So this is about developing a kit of parts for building in wood, a design of buildings, of systems of construction, which is designed not only for manufacture and assembly, but for disassembly. So taking us through the kind of like the prefabrication of that building, the accuracy, the quality that's achievable through that kind of process, building, planning, designing for efficient transportation, speed and ease of installation, safe, clean, non-hostile working environments on construction sites. And also thinking, as I was saying, about that disassembly, about the end of life, and how we can reintegrate that timber back into the supply chain. And developing an understanding of an adaptability as well. So thinking about how we can adapt those buildings from residential to office buildings, from office to residential, looking at different grids, and from those grids, planning out different kind of parametric modeling tools that we can then work through in different systems of construction. So post and beam, post and slab, all different kind of natures of construction, looking for efficiencies in each one of those through design for manufacture. Just a brief kind of introduction to one of the projects we're working on at the moment. We're working with a number of target cities across Europe, both in the UK, Sweden, Norway, and elsewhere. This is a project in Norway, working with the Norwegian Technical Institute in Trondheim. And this is for low-cost housing. It's an existing 3-story concrete frame building for a housing association. And what we're doing is looking for opportunities to extend that building by 2 stories. So working, I mean, you can see working very closely with concepts with the housing association around clients, existing occupiers, housing need in Trondheim, and looking at how we can extend those existing buildings using the strength of the existing concrete structures in order to enlarge those buildings. So we have a few of these types of projects across some of our target cities. And that, once completed, will be a revitalized building, better insulation, increased insulation around the building, new heating systems, new passive energy systems, and 16 additional homes, plus the amenity on the rooftops. Closer to home in the UK, we are also looking at how we can work with the changing building regulations, how we can work with insurance agencies, local authorities, city boroughs, etc., and to provide them with an opportunity to build zero carbon housing, or as close to it as we're ever going to get. So talking to them about timber systems of construction, looking at the difference, really, the opportunities, demonstrating to those bodies the opportunities that we can get by building in timber. So with this new model building, we know that we can take the baseline, the kind of current benchmark for construction and operational carbon, nearly 2,500 kilos of embodied carbon there, and taking that down by building in timber, reducing the embodied carbon of our buildings by more than 2/3. and that once we bring that down with the energy targets signed up to in Paris, we can really see significant reductions from current construction practice. And we can see the superstructure for timber in that new model building representing less than 12% of the embodied carbon of that building. So just the foundations, the ground floor concrete slab, etc., representing nearly a third of that embodied carbon. And this is a project in Paris, recently completed, built very much to that model. So that's a prefabricated elements, prefabricated bathrooms, kitchen elements, and facades here. You can see in the factory here on the left-hand side, the zinc facade of a prefabricated balcony and window element that is then craned into place on site. And that project now completed, and 54 low-cost housing apartments now occupied. And I'd just like to finish there with the handful of seeds. And this is the number of tree seeds that grew the trees that built our first tall building, Murray Grove. Thank you very much.